All right, today we're looking at one-to-one functions and inverse functions. So a function is one-to-one. If no two elements of the domain correspond to the same elements in the range. So that means each input has a unique output. Unique. So if we're going to look at some examples, starting with a mapping. So if you look at that first mapping, it is not even a function. It's not a function. How do I know? Well, because I have the x's repeating. X's are repeating there. And then I look at the second example, and it is a function, but it's not one-to-one. And why? Because these x's, they're not going to a unique y. They're going to the same y. And then that third example, that is a function and it's one-to-one. Why? Because each one of these x's has its own y, its own unique y. Looking at ordered pair, this one, first one, is not a function. Why? Why is it not a function? It has repeating x's. Repeating x's that are going to different y's. And we'll see that right here. Now, if you look at that second example, x's are all different, but we've got some y's that are the same. So that's a function, but it's not one-to-one. And then the third example, x's are all different, y's are all different. So because each x goes to a unique y, this is a one-to-one function. No repeating y's or x's. X's or y's. Now what about from a graph? Well, we know to determine if something is a function when we do our vertical line test. But to determine if something is also one-to-one, we do a horizontal line test, which we can see right here. Oh, found it. So that's a function, but it's not a one-to-one function. If you look at the second example, passes the vertical line test, but it also passes the horizontal line test there. So it has to pass both the vertical and the horizontal. Does both, it is a one-to-one function. And what's going to be important about that is that, excuse me, one-to-one functions have inverses, so we can find an inverse of a one-to-one function. So what is an inverse? So let f and g be two functions. If the f of the g of x is equal to x, and the g of the f of x is equal to x, then f and g are inverses. They are inverse functions. So to put it simply, if the f of x and the g of x are inverses of each other, then the range, or the domain, vice versa, domain of the f is the range of the g, vice versa. Also, think of it this way. An inverse function undoes whatever the function did. It's always denoted. The inverse is denoted by inverse function. It looks like it's a power, but it's not. So let's look at some examples. This example, I made a mistake on it, so we are going to change this. It's going to be a 5, because it wasn't even a function. So that's a function, now that I fixed it. And to find the inverse instead of ordered pair is easy. Just flip-flop them. Really helpful when you're graphing. That's all you need to do is flip-flop them. And we can see that all of our x's are unique, all of our y's are unique. Looking at a mapping. So a mapping, we're going back to what I said about them undoing each other. So let's just try something. Here's our f of x, here's our g of x. I'm saying those are inverses, and let's test it. If I plug a 2 into, that's my domain. If I plug a 2, domain of f. If I plug a 2 in, what do I get out? I get a 4. So now if I take that range, that's my range of f, it's is now my domain of G. If I plug that in to G, 1/2 of 4 is 2. That's my range of G, which is the same as my domain of F. Remember how I said that at the beginning and it sounded like, is that true? So looking at working it the other way around, let's say I put a 2 into G. This is my domain of G now. Put a 2 in, what's 1/2 of 2? That's 1. My range of G. Now let's say I take that range and I use it as my domain. So now this is my domain of F. Plug that in. 2 times 1 is 2, and that is my range of G. See how that's related? Domain of G, or range of F. Sorry. Range of F and the domain of G are the same, it's just like the range of G and the domain of F. Graphically, the graph of the inverse of a function is the reflection of that function through y equals x. So different, not the y-axis or the x-axis or the origin. It's through the line y equals x, which you can see. There's a graph right here, and you can see this example where we have the function here, and then its inverse is a reflection of that. And in fact, every point AB that lies on the function corresponds to a point EA on the inverse. We talked about that with that ordered pair. So here's an example. We want to find the inverse of this. Well, we're just going to reverse each point. This point right here is -3, -1. So point on our inverse would be -1, -3. This point is 0, 2, so it would be 2, 0. On our inverse. This point right here is 2, 2, well, 2, 2. And then 3, 3, 3, 3. Right here is if you think, if I drew that y equals x through here, it would be a reflection through that one. How do we verify something is actually an inverse? Well, we've used that definition when we said the f of g of x is equal to the g of f of x, and they're both equal to x. So we're going to verify that this inverse is actually the inverse of that function. So we'll start with the, let me change my line back, the f of the inverse. I'm going to plug it in and see if it works. So 2, and then instead of x, I'm going 1/2 x minus 2, because that's my inverse. Maybe plus 4. And then I'm going to clean this up. That's x minus 4 plus 4. Those cancel, so we end up with x. So that won't work. It's not good enough for one. We're going to check both. So we're going to plug into the inverse, the original function. So 1/2, instead of putting x, I'm putting 2x plus 4 minus 2. So that is x plus 2 minus 2. Those cancel. So it is x. Those are inverses of each other. How do we find the inverse? We're told something's 1 to 1, we know it has an inverse. What would we do to find it? Well, I'm going to follow these steps. You already know, many of you have proven that on replace f of x with y, just because it's easier. That's not necessarily a needed step, it just makes it easier to do. Now we're flipping x and y. So x is equal to y minus 1 over 2. Follow these steps. Did that one, did that one. Now we'll solve it for y. So multiply by 2. Be good equation solvers in here. 2x plus 1 equals y. Did that one. And then that's the inverse. The inverse of my function is 2x plus 1. Wasn't really 100% sure I could verify it, but I did what we did above. I'm going to find the inverse of both of these. So y is equal to the square root of x plus 1. Flip x and y. So x is equal to the square root of y plus 1. get rid of square root by squaring. X squared is equal to y plus 1, minus 1 to both sides. Y is equal to x squared minus 1, and then that gives you my inverse. Next one, exponentially. They'll be able to do with all of them. So y is equal to 2 to the x. Flip the x and y. So x is equal to 2 to the y power. Well, knowing our laws on logs, that means that this is the log base 2 of x, and that's equal to y. So that is our inverse. Inverse of our function is log base 2 of x.